Hello, everybody. We're going to talk about sections 3.2 and 3.3. Equations of lines. We're going to define a couple of terms. You're probably familiar with many of these, but we're going to go through them anyway. And you're probably most familiar with slope-intercept form. But we're also going to talk about a couple other forms of lines. Okay. First, we're going to define slope. Now, slope is a term that applies only to linear functions. Okay. And slope is defined as the ratio rise over run, where rise is defined is the vertical distance between 2 points, and run is the horizontal distance between 2 points. Your rise is the vertical distance, how far up and down you go to get to the next point, and the run is the horizontal distance, how far right or left you go to get to the next point. Okay, so sometimes we call the rise the change or delta y, and the run is the change in x between 2 points. So the way that you find that, if you have 2 points, let's say you have an x1 comma y1, that little subscript is 1 because we're talking about the first point. Second point is x2 comma y2. So you're going to find the change in y's. So y2 minus y1, you're going to divide by the change in x, which is your run. How far was your change in x? x2 minus x1. Okay. And there are 4 types of slopes that we'll talk about. You could have a positive slope. I'll give you an example. Let's say we have something like y equals 3/2 x, and let's say plus 3. Okay, your slope is up 3 over 2. Y-intercept is 3. So 1, 2, 3. That's your y-intercept. And this thing right here is your slope. So we're going to go, the rise is up 3 over 2. So 1, 2, 3, 1, 2. So if you're going back the other direction, now you're going to go down 3 and left 2. And so there's your slope, positive slope. You can think of positive slope as going, if you're going left to right on your paper, kind of like the way you write on any piece of paper, you go from left to right. As you're going left to right, are you going uphill or are you going downhill? Slope is positive, we should be going uphill. Now let's say this was almost the same, but now we want to show a negative slope. So we have an example would be y equals negative 3/2 x plus 3. So our y-intercept again is 3. But now it's a negative slope. So we know going left to right, we have to be going downwards. Okay. And the change in y is 3, so we're going to go down 3, and then we're going to go right 2. So another point. Okay, so if we're going left, we would now go up 3 and left 2. Right, so that right there is going to show you a negative slope. Okay. And then the other 2 types of slopes, the zero slope. So we could say slope is 0. So that's any horizontal line has a slope of 0. Let's say we're at y equals 2. Okay. Anytime your y is equal to a constant, y equals k, or any one constant, you're going to have a horizontal line. Okay. If you're to take 2 points on here, let's say we're taking this point, let's say we take this point, 3, 2, and let's say this point here, 1, 2. Your change in y would be 2 over 2, or 2 minus 2. Change in x would be 3 over 1, 3 minus 1. So you get 0 over 2, which is 0. The slope is 0. And if you think about y equals 2, that's a fitting name for this line because every point on this line is going to have a y value of 2. So we simply call the line y equals 2. Okay. Now, if your x is a constant, let's say x equals negative 5. 1, 2, 3, 4, 5. Then we have a vertical line. Okay, because for every point on this line, the x is always negative 5. You could talk about this point, negative 5, 0. Let's go up 2. This would be negative 5, 2. Every point on this line, your x value is negative 5. Notice the y can be different values, but the x is always 5, so we call it x equals negative 5. And if you find your slope, the change in y, you're going to get 2 minus 0 over the change in x, negative 5 minus a negative 5. And now we get 2 over 0. Well, that's an undefined slope. So we're going to call this slope is undefined. Okay, so you have a positive slope, a negative slope, zero slope, or undefined slope. Okay. And then we go to the next page, and I'm going to, maybe we'll do one of these together. Let's say number 6. So what we're, at this point, what we're most familiar with is slope-intercept form. So what we would do is get the y by itself. So subtract 4x from both sides. Divide everything by negative 3. Y equals, that becomes positive 4/3 x minus 4. Okay, so your y-intercept is down 4. 1, 2, 3, 4. Your slope is positive 4/3. So up 4 over 3. You really only need 2 points to make a line, but let's do another one. 1, 2, 3, 4. 1, 2, 3. And you could draw your line. Okay. Some of these other ones, like this one's already in slope-intercept form. Slope-intercept form just happens when you get the y value by itself. And then you're pretty much naturally in slope-intercept form. Okay. I will post, I'll do the answer key for this so you can check your work, but I don't think I need to go through that on video, and I will post this. Okay. Let's go to the next page, because this is just one of the 3 main types, forms of a line. The other forms of a linear function, okay, we've got slope-intercept form, which we just talked about. The general formula for that is y equals mx plus b, where m is your slope and b is your y-intercept. That's where you cross the y-axis. Slope formula, once again, is rise over run, y2 minus y1 over x2 minus x1. Point slope form looks like this. Y minus y1 equals your slope times x minus x1. Okay. And then finally, the last form we're going to talk about is general form. And general form is ax plus by is equal to c. Okay, where a, b, and c stand for constants, and typically we want them all to be integers. They don't have to be, but I might specify they should be integers, but your a value should be positive. So we're going to say where a is greater than 0. Let's say greater than or equal to 0. Because if there's no a, if a is 0, then you just have no x term and you simply have a horizontal line. Okay, and if a is not greater than 0, then you just multiply both sides of the equation by a -1, and then a will be positive. Okay, so what's the uses for all of these? Well, this one is most useful when you have when you know the slope and the y-intercept. Best when you have or you know the slope and the y-intercept. For example, they might tell you find the equation of line where the slope is 5 and the y-intercept is -3. Well, you just plop them right in. Y equals 5x minus 3. Okay. Or if you have the line, then it's just really easy to graph. You go to the y-intercept and then you go up 5 over 1, positive 5 slope. Okay. Here, the best use for this one, best when you have, what do you think we need for this one? Well, a point and a slope. When you have any point on the line and you have a slope of the line. So for example, find the equation of the line that passes through the point, let's say 2 comma -7, and has a slope of equals 2/3. Okay. Well, this thing is your one specific point. We'll call this x1 comma y1. You plop that point, the 2 you plop in for x1 over here. The -7 you plop in for y1 over here. And then you're going to plop the slope in right here. And that's it. You're going to get y. That becomes a +7 equals your slope. So 2/3 and x -2. Okay. Now notice, any point that exists on this line can be plopped in here. Okay? And once you multiplied this out and got the y by itself, you would get one unique form of slope-intercept form. Okay? And finally, general form is best when you want to plot something. I think it's best when you want to plot something if you just want to plot your two intercepts. Okay, best when you're graphing by plotting your intercepts. Okay, by intercepts, I mean the x-intercept and the y-intercept. So let's use an example, and I'm going to use a convenient example. Let's say you've got 3x minus 4y is equal to, it's most convenient if this number over here is a multiple of both of those, just because you're going to get nice integer values. Okay. Now you're going to apply your intercepts, your x-intercept and your y-intercept. Okay. Well, your x-intercept happens when your y value is 0. Your y-intercept happens when your x value is 0. Okay. That should make sense. Think about any line. This is your x-intercept. And no matter where you cross the x-axis, you know that your y value is 0. That's going to be your x-intercept. Maybe this is the point 5 comma 0. This point, which is your y-intercept, anytime you cross the y-axis, you know your x value is 0. Okay. And that might be 0 comma 2, something like that. I just threw this out there. I just made that up. So that's not from this problem here. Let's now find our x-intercept. Our x-intercept happens when we plug in 0 for y. So when you plug in a 0 for y, -4 times 0, that goes away. So you get 3x equals 12, and x would equal 4. And then the y-intercept happens when x is 0. So we can plug in the 0 for x. 3 times 0, that goes away. And we get a -3. And you simply plot 4 comma 0, 1, 2, 3, 4, and 0 comma -3. The nice thing is you only need 2 points for a line. So your intercepts, and again, this turned out, you might get fractions here if this is not a multiple of both of those. Okay? But it's still pretty easy to find your two intercepts. Okay. Now looking at these down here, plot the graph in point slope form. Showing clearly the point and slopes that appear in the equation. Point slope form means start at the point where x minus x1 equals 0. Or if you recognize this pattern up here, your x1 would be the number that is subtracted from your x. So x1 would be 4. So you can look at this and say, I'm going to pass through the point 4 comma 3. Or you can set this equal to 0 and solve. Set this equal to 0 and solve, and that's going to give you your point. My slope, I know, is 1/2. Okay. So we go to 4 comma 3, 1, 2, 3, 4, 1, 2, 3. There's our point that we know is on the line. The slope is positive, rise over run, up 1 over 2, up 1 over 2, up 1 over 2. Continue the trend the other direction. And you've got your line. Okay, so showing clearly the point, the 4 comma 3, and clearly the slopes. You can see I went up 1 over 2, up 1 over 2. Okay. And I will post the answer key. I'll finish the rest of these problems, but that should be good for now.